Hi guys, hi everybody. My name is Hasan Zeki Alp. Welcome to my YouTube channel. Welcome to Modern Languages, Programming Languages lectures. And this time I'll gonna lecture you our language lesson 3. And just I trace back for the previous lessons. I have I have registered and broadcasted the first lesson at 27th of October. This was the first lesson, and the second lesson just recorded and broadcasted at 6th of November. And so far, since then, approximately a whole month passed, and I think it's time for another lesson. I would like to remind you about our programming language lessons. For presenting such lessons, I've been using RStudio and RStudio IDE environment. This is what I preferred for presenting these lessons, and I have already prepared some code snippets and some syntax information just to present you. And after presenting you, after running the code to show you the result, and our lessons will go like this. And without wasting any time, I'd like to start up our lesson 3 for RStudio. Okay, we're starting with lesson R demo 21st, and here I define a variable called v, and it's a vector, so it's gonna have 3 members, 2, 5.5 and 6. And here I define another variable here, st, and so it's gonna have 3 members also, such as 8, 3 and 4. So I'd like to find out v plus t, and after adding this 2 vectors, I would like to print out on the screen. This is the quickest way, or the easy way, and this is the longest way. Instead of placing operation here, v plus t, just we could manually place the first one and the second one. Just after running this code, I will have the same result for this one and this one. I intended to show you the both methods, the both ways, so as to present you. And you can see once again here, (10.0), 8.5, 10.0. Just when we add 2 numbers, 2 plus 8 becomes 10, and 5.5 plus 3 becomes 8.5, and 6 plus 4 becomes 10, and this is repeated for the longest version also, as you can see here. Okay, and this was the R demo 21st. Let's go with 22nd. I here define the same vectors once again, such as t and v and t, and this time I would like to print out v minus t. It's so easy. Just I have to show you the result. Okay, minus 6.0, 2.5 and 2.0, because 2 minus 8 becomes minus 6, and 5.5 minus 3 becomes 2.5. And let's go with another code snippet here. This time I'd like to get it multiplied by 2 variables, v and t, and just as you can expect, 2.8 becomes 18.0, and 5.5 and 3, when it is multiplied by, it's gonna give 16.5, and 6 multiplied by 4 will result 24.0, like this. This is ordinary vector multiplication. And how about snippet 24? Okay, this time I'd like to show you division of these vectors. I mean v divided by t, and when we run this code snippet, it's going to give a floating point number dot 2540, and how about this one, 5.5 divided by 3, and it's going to give this 1.83, and 3 is revolving. And how about the last element, 6 divided by 4, it's going to give 1.5. The result of this command. Okay, this was 24. Okay, let's go with 25. This time I'd like to show you modulo arithmetic, or other saying division with remaining. This both are the same, in fact. Whichever you prefer, it is up to you. And this time 2 divided by 6 with remaining will result 2, and 5.5 divided by 3, it's gonna give 2.5, and 6 divided by 4 with a remaining of 2. And let's make it run, and to show you, okay, just 2 divided by 8, it's gonna give 2, okay, because it's not multiplication of 8. At least it should be 8 or greater than 8, so I have to give a remaining part. And how about this one, 3.5, such just as I said before, and this one also 2.0. This is called modulo arithmetic, or division with remaining value, because we are accepting the remaining value, not the division itself. Okay, let's go with another code snippet here. Demo26. Here I use this time such configuration. This is gonna give the remaining division. This is the division part. Okay, 0, because there is not a one fold of this one. And how about this one? This is the only one times, and this is only one time. You guys, this presentation, this symbolic presentation is a new feature for R. In fact, as far as I remember, there is no such a feature for Java and Kotlin and Python itself. So far I have not met such a features in other languages. This is an extra for our programming language, yes, I can say. The difference is that this is the contra of modular arithmetic. It's gonna give the division value, okay, not the remaining value, however, division value. Okay, this was demo 26. How about 27? Okay, here and our first variable we suggest the same, and this time we are looking for this operand, this operation. This stands for the exponential, in fact. So This the first element stands for 2 to the power of 8, in fact. To the power of 4 becomes 16. Okay, the other part, to the power of 4 becomes 16. Oh, and 16 times 16 becomes 256. And how about this one? 5.5 to the power of 3. So that means 3 of 5.5 will be multiplied in a sequence manner. So it's going to give 166.375. And how about this one? This is going to give a result of this one that can be calculated like this. 6 to the power of 4. That means 6 times 6 is going to give 36, and another 36, and 36 times 36 is going to give 1296.0. This is the exponential operation, exponential sign. This was the 27, and how about 28? Okay, this time just I'll interrogate. I will query about this condition. That means we'd like to print out the ones that must meet this condition, this comparison. Okay, how about the first one? 2 is greater than 8. No, it is gonna give false. 5.5 is greater than 2.5. True, yes. How about this one? 6 is greater than 14. No, false once again. 9 is greater than 9. No, equals but not 5. It is gonna false once again. Okay, the first one false, the second one true. Okay, just this one meets the condition, in fact. And how about this one? Does not meet the condition. How about this one? This also, this both do not meet the condition, in fact. Just the second component, the second element meets this condition. That means it's going to give true result, because 5.5 is greater than 2.5. Okay, it's clear, I think. This was 28. How about 29? Let's go with 29. This time just we'll query about the ones, the members less than the other one. So 2 is greater than 8. Okay, this is true. 5.5 is less than 2.5. No, false. How about this one? True and false. True, false, true, false. Okay, the result just as we expected, because in this case we are inquiring we less than t. Okay, this was 29. How about 30? In this case, just we are comparing the components one by one once again, and this time just I'd like to try to find out whether is equal to this one. So that's gonna give false, because none of the elements are the same with the other one. In fact, 5.5, 2.5. No, just only one, this one. Okay, 9. We cached it here. 9 equals to 9. So just the last member of this vector becomes true as a result of this comparison. Okay, because the last example, the last element is the same with the other one. Okay, 31st. Okay, greater or equal to t. Okay, just we're inquiring this time. This is not for. This is false. This is true, and this is false, and this is true. False, true, false, true. The result will be false, true, false, true. False, true, false, true. Because we are inquiring greater or equal to t. V is greater or equal to t. And this was the 31st, about 32nd. This time, is it the same? Okay, we have already done it. 33. This time we're using heterogeneous members such as 3, 1, logical 2, true, and complex number 2.2 plus 3i, complex number. This is the real part, and this is the imaginary part. And just we are expecting so as to be calculated after v and t. This is a logical operation, in fact, and the result will be printed as a result of this logical operation one by one, after considering one by one, like this: 3 and 4, and 1 and 1, true and false, 2.2 and 3i, 2.3i, and let's make it run and see. Okay, 3 and 5. When we this one, this is greater than 0. Okay, this is also greater than 0, and the result of this one false, because true and false will give a result of false, and this was also true, because both of them are the same, and as a result of this operation, this print method, v and t will give this result: true, true, false, true. 33. How about 34? It's a repetition, just I have to go with another one. This time, this is OR operation, logical OR operation, in fact. Just we are inquiring the result of logical operation. 3 or 4 will give a result of true, and 0 or 0 will give a result of false. This will give true. This will give false. This will give true, because it is enough. One of the operands is true. The result will true, in fact, and this is also true. And the only one, the second one will false, and the other will give a result of true, in fact. Okay, just as I said. Just the second element will give a result of 0, because none of the elements is 1, and so will the result will 0, false. That corresponds to false case, false situation. This was the 31st. How about 36? Our demo file 36. Here, this is the negation, or the complementary of V, in fact. Just we'd like to print out here 3, and this logically corresponds to 1, 0, and this logically corresponds to false. However, as a result of this negation, it's going to give a positive true result. This is going to give a false result, and this is going to give a false result, because this is this will give a positive true result, and the negation of the result of the negation of this v is going to give a false result. Just I'd like to show it to you. The first one will give a result of false, and this is going to give a true, and the others will give a false, because this is logically true, and this is corresponding to logically true, because is greater than 1. That means this corresponds to logical true. And as a result of this negation, this exclamation mark, it's going to give false, the remaining parts. Okay, this was the 36. How about 37? 37. Okay, I here would like to see the result of this operation, bitwise operation. Okay, just this is bitwise, and just as a whole, I'd like to give the result for this one, and this is going to give a result of comparison, logical comparison, in fact, and 3. It's going to look for the first element. In fact, the first element will enough to give a result of 1. In fact, okay, this is the true. In our language, it's a assumption that it's a definition. As a definition, if the first elements meets this condition, okay, this is gonna give a whole result. That was 37. How about 38? Okay, and this time logical or this will give a false, because the first elements are compared as logical condition, and it's going to give a false, in fact, because the first element will give a result of false. That's enough for this operation, for this logical comparison. 38. How about 39? Okay, here I define 3 variables here, such as the v first, v second, and v third, and these are some notation here, like this, and 4 members in heterogeneous manner. 3, 1, true, 2 plus 3i is complex, and the other one. So I would like to print out the equivalent values for v1, v2, and v3, and in fact the same vector will be used, and in this case I'd like to assign this way, and that way also, and I'd like to assign as equality condition. So when we print out, I will show you, and 3 plus 0i, and just look here, you guys, because this was the first complex number. However, the others should be converted into this one. Okay, and just we'd like to repeat the multiplication value. 3 times 1 plus 0 times I. That means only 1, the real part, and this was also 1 times the real part, and 0 times the imaginary part. That's gonna give only 1. And how about this one? 1 plus 0i once again, and this is also the same, and this is repeated for the other one also, and the same result. And just this is another notation so as to be used for this one. Just it is up to you which one, which notation you prefer. It's gonna give the same resultant notation. In case one of these one is false, becomes false, so the result will only 0, not one real part. Okay, this was the 39. How about the 40? Less than 40. So this is another notation. Just you can prefer this one. Our language gives such a possibility to use this one also, and our C vector is constituted by 4 heterogeneous members, 3, 1, true, 2 plus 3i, and this is gonna assign to v1. Just you can see the orders. It doesn't matter in R as long as this value is assigned to this variable. That's okay. It's accepted by the compiler, by the interpreter, and this is also the same for v2. And I'd like to print out v first and v second. It's gonna give the same result. Okay. Once again, it's converted into complex number configuration presentation like this. Actually, just you can say that 0.ei just that means 0. However, is in order to for the sake of reading easily, this is preferred like this by our standards. Yes, this was the end of lesson 3, you guys. And this was the end of lesson 3, you guys. So it's gonna elapse, take 28 minutes. I'd like to cut this lesson here. Otherwise, I will have some uploading problems, you guys. That's the end of this lesson. And thanks for your watching me, and thanks for your time. Bye now.